scaling laws for forgetting when fine-tuning large language models. So it talks about catastrophic forgetting. So what happens is when you fine-tune a model to do something like play Towers of Hanoi really, really well, you get what's called catastrophic forgetting. Catastrophic forgetting is when the retraining eliminates stuff that it's learned before in order to kind of make space for stuff that it needs to learn now. So I believe it's on, section 2. Let's go down to section 2 here. So this was a problem that was brought up in the early 90s. When a neural network trained on a task was further trained to learn a new task, performance on the first task catastrophically degraded. This forgetting was given the moniker catastrophic forgetting and continues to be a problem. They struggle they're still struggling to solve this even now when you do retraining or fine-tuning. So anytime this is one of the reasons why Geppetto 03 came out and it had higher hallucination rates, because they were fine-tuning it for something and it caused higher general drops in its capability of things that it was more capable before. The scaling laws make it even worse. Larger models are significantly more sample efficient, and that's great. But what happens is that it means that they actually suffer more from catastrophic forgetting. The reason why is because once they've chosen a path to remember something, they like reusing that path for future training. And the more room you give it, for the more available paths you give it, the more the initial training is going to pick a bunch of different paths and then stick to them more and more and more. So as you scale up the amount of training and data that it gets, you're actually just sticking to more paths. Smaller models suffer from this as well, but they do so in a kind of like a different way, in that they'll use up a smaller amount of paths so they can end up being fine-tuned better. So they're going to have like a fine-tuned quality output that's a little bit better because they don't have as much data to pick from, but it means that they're going to suffer from quality of being able to do that. So it's a little bit of a different game with smaller language models. Larger language models are just like, hey, I like this path, I'm going to reuse this path and give me more, and then it just continues to use the same paths. That's essentially kind of like the generalization of this. So this catastrophic forgetting stuff, it's a known unsolved problem. It will just continue, and no, throwing more data and computational power at it doesn't help. It actually makes it worse. Model editing harms general abilities of large language models. Regularization to the rescue. This is kind of the same kind of deal. When you start fine-tuning it for things like here, I just wanted to show this because it's kind of funny. You edit the model in order to do a few things better, maybe add more tweaks like biases and weights on certain outputs. Make sure when somebody says the sky is, you follow up with blue. Unfortunately, it comes with other consequences. Who is the current president of the US? Before editing, Donald Trump. After editing, Joe Biden. So just another one to put on record. There's so many of these. It's crazy.